Audio Jungle. Audio Jungle.
All right. So, like we had seen that aerodynamic coefficient, that formula and all, dependency also we have seen. Now we'll go for next sub part of it. It's obtaining lift coefficient. Lift coefficient from pressure coefficient. Okay, very good. Now, so lift coefficient means CL. You are going to calculate. Okay, you are going to get that lift coefficient from pressure coefficient. Yes or no? From pressure coefficient. So CL you are going to get from CP. Okay. Now, so very important here. What is the pressure coefficient? Lift coefficient you have seen, but what is the pressure coefficient? It is nothing but Cp. If you remember, it is explained already. Just like a dimensionless number, lift coefficient, dimensionless quantity, better to say. Lift coefficient is dimensionless quantity. Drag coefficient is dimensionless quantity. Tm moment coefficient is a dimensionless quantity. Similarly, we have a pressure coefficient which is also a dimensionless quantity. Okay. How to get it? That formula that day I explained. Pp it was given. It was derived also that day. Last few lectures, if you go back, then you may get this derivation we had already we had done. So Cp is nothing but it's a, because it is a dimensionless quantity, so obviously it will be the ratio of the, maybe it is just like a lift coefficient, so it's a ratio of the forces. Similarly, this is the pressure coefficient, so this is the ratio of the pressure. So P minus P infinity divided by dynamic pressure, which is nothing but Q infinity. Yes or no? P minus P infinity divided by Q infinity. What is the Q infinity? 1 by 2 gamma P infinity M infinity square. Yes or no? Check it. Q infinity, that formula 1 by 2 gamma P infinity M infinity square. Okay, this is what pressure coefficient. All right. Why? What is the use of it? So its use is very important in terms of the generation of lift forces. Lift force basically. Okay. And obviously drag force also you can get from the pressure coefficients. So this pressure coefficient is basically the pressure distribution, okay, over the top surface of an airfoil or wing, okay, and similarly below the top surface, which is nothing but bottom surface, because pressure distribution will be there, both side pressure distribution will be there. If I show you, so suppose this is the airfoil here, okay, and airfoil is the cross section of the wing, so I am just drawing the wing also. So this is the wing. Okay. So pressure distribution of the, suppose flow is there, so there will be the distribution of the pressure. Why? Because the wing, it is submerged, it is inside the fluid, and what is the fluid? It is air. So obviously there will be the pressure also, maybe dynamic pressure, maybe static pressure. Okay, this is what pressure distribution, right? So this is on top surface. Similarly, pressure distribution you may have on bottom surface also. This is on bottom surface. Yes or no? Top surface and bottom surface. So bottom surface we can show you here by this way. Okay. Top surface, it's a here. Huh? Yes or no? So it should be very clear here. It should be very precise also. Okay. Fine. So this is what bottom surface, bottom surface, or you can say lower surface. So here pressure will be PL because it's a lower surface, and pressure coefficient will be CPL. CP is the pressure coefficient, L is means indicates lower side. Similarly, this is what upper surface or top surface. What will be the pressure? PU or CPU, pressure coefficient, upper surface. Yes or no? Pressure coefficient on lower surface, pressure coefficient on upper surface. All right. So I can show the distribution of the pressure over top surface and lower surface. So you may get the pressure distribution. This is the pressure distribution basically. What here I have shown you. This is the pressure distribution over the surface of wing. If you say airfoil, so you can talk about airfoil also, no problem. Airfoil, if you say, it becomes 2D. Wing, if you say, it becomes 3D. That's the only difference. Okay. All right. So if I show you the pressure distribution by plot, pressure distribution. If I show you the plot, not correct. So okay, all right. So what will happen actually on lower side and upper surface and upper surface, if you are talking about the lift force, so definitely lower surface and upper surface will have a pressure distribution, and both should have a difference of it, no? Then only you will get lift force, otherwise how you will get force? Lift force is what? It's a pressure difference in upper and lower surface, yes or no? So this is what? Lower surface, okay, and this is what? Upper surface. You can follow any book that for this pressure coefficient and pressure distribution, which is called one Horton and Kuruthar. Yes, that book you can check, aerodynamics book, Horton and Kuruthar. Very nicely they had explained the diagram and all. Maybe here a diagram I have not done, not drawn properly, but yes, there you may get properly. Okay, so like here, let me. It should be like this. Here. Okay. So upper surface, obviously upper surface there should be negative pressure. Negative pressure means it should be less than atmospheric pressure. Okay. So hence it is minus. Similarly, lower side it should be plus. Okay. So it is very clear. Okay. Like here I have shown you upper surface and lower surface. So if you say what is the mean of it? I mean, why this pressure coefficient I am drawing here? This is the pressure coefficient Cp versus chord length, no? X by C. Okay. This value here it is 1.0. 1.0 means the whole chord length you are talking. I will show you here. It's very simple only. You need to concentrate, you may get automatically. This length is nothing but what? Chord length. X is the fraction length from leading edge to trailing edge. This is leading edge. This is what? Trailing edge. Yes or no? So if you go for the wing, so wing means here this is no wing. Okay. Half portion I have taken. So for this wing, this is what? Upper surface. So if I say I'm getting lift from this wing, so what is the mean of it? What is the mean of it? If I say lift force I'm getting upper direction. So how I'm getting this? It means that bottom side pressure will be very high. Bottom side pressure means this one. Bottom side, bottom surface, you will have a high pressure. Okay, should I take this color? Bottom side pressure is what? Very high compared to upper side. Yes or no? This is the bottom side pressure over the surface. Okay, and top side pressure you can say it is comparatively it is less. This is a top side. Yes or no? So What is the lift force? Lift force is the like difference. Bottom side pressure is very high and upper side of the wing pressure is less. So from high pressure to low pressure, you may get lift force. Pressure into area will give the force. Yes or no? So distribution over the wing, you may get like this. See, so upper surface you may have negative pressure. For that reason, these all value are negative, minus 0.5, minus 1, minus 1 point pressure coefficient, minus 2. But lower surface you may have a high pressure, positive pressure. Positive means more than atmospheric pressure. Negative means less than atmospheric pressure. So this will be the diagram. This is the basically pressure distribution. Okay, I am not going in very deep and detail. So just connect it. Okay. So if you say like how to find that lift coefficient from this CP, okay. So again there is a very big derivation, okay. So I'm not going in that because if if you go then it will take so much time, okay. In short, I just want to tell you because over the surface of the wing again I'll tell you that normal force and axial force, just like over the airfoil I had explained normal force and axial force. So how to get that normal and axial force? Okay. So you may get the formula I am writing you. So you may connect and you may get it easily. Check. I am just saying this wing we have, okay. For this you are going to calculate the normal and axial force, because once you get normal and axial force, so you may get the lift coefficient. Suppose this length is what, S. Okay, what is this length? S. Okay, one element I am going to write cut here. For that element I am going to show the all calculation of normal and axial force. So what will be this length? This is nothing but ds. In short I am going, very short I am going, okay. Ds length. Obviously this will be what? Leading edge, and this will be what? Trailing edge. Okay. There is no doubt from the, because if you check, this is the chord length, and from the horizontal there will be angle. What angle? Alpha, which is nothing but angle of attack. Horizontal, this is the reference line, as you said. Okay. Now for this ds element you are going to calculate what is the normal force and what is the axial force. Upper side pressure I must say it is Pu, lower side pressure it is nothing but PL. I told you pressure distribution, 2 times I have drawn the diagram. Check this. This is nothing but upper side you can say it is Pu, and lower side pressure distribution it is PL. Just like here I explained here. No? Pu upper surface and lower surface it was PL. Okay. So now for this ds element you are going to calculate what? Normal force and axial force. Okay. So directly I am just going to write what will be the normal force. So normal force N, because this is the small elements you are going to take, and for this element if you integrate from leading edge to trailing edge, then you will get for complete wing, and it is nothing but PL, because on the surface exactly normal force is what? Perpendicular to the chord line, so obviously theta term will come, and that cos component you have to take for the normal force. You can do that force resolution and all, it's simple only there. And similarly you can do for the leading edge to trailing edge for the, this is for the lower component, lower lip pressure distribution PL. Similarly you can do for the PU. So this difference between PL and PU will give the normal force, and that normal force again you will get component, then you may get lift force and drag force. Yes or no? This is what normal force. This also you can write, because leading is to trailing is, what is this total length? This total length is nothing but is what? If you check, this total length was, it is chord length C. Now I have drawn in the previous diagram also. See, this total length is nothing but leading is to trailing edge, it is chord. So you can write 0 to C PL cos theta ds minus 0 to C PU cos theta ds. Okay, all right. This cos theta ds, okay, like in this I told you this is the elemental length or the surface S, and ds element you had taken. So this diagram, if you focus on this small triangle you may get, and what is the triangle? This is what ds, this is what, this angle I am saying, this is what theta, not, I should draw largely so you will get clear. Okay, horizontal angle will be what? Theta. This, check, this is the small triangle you may get here, a small triangle will be formed. So this length is nothing but ds, what I have written here, and horizontal length I am considering this length in a horizontal direction. In a horizontal direction, just like this is s, so this horizontal direction it is x, so this is nothing but dx. All right, horizontal, parallel to chord, you can say parallel to chord. All right, so you tell me what is the cos theta dx by ds. What is the dx? Ds cos theta. So here ds cos theta we have, here also ds cos theta we have, we can replace by dx. So what is the normal force? Normal force N will be 0 to C. In very short I am trying to explain here. It is PL dx minus 0 to C PU dx. Done. This is what normal force. What is this normal force, and where you had seen? Check in starting only. Here I told you component. See, this was the normal force. Yes or no? Normal force. A was the axial force. Axial means parallel to chord. Normal means perpendicular to the chord. Yes or no? Check here, normal force and axial force. So that I am calculating, because once you get normal and axial, again component you can take, so you can get lift and force, lift and drag. Okay. So this is the, now similarly you can calculate axial force. So like for normal you had taken cos component. So similarly for axial also you can write. So for axial what you may get? For axial you may get obviously sine component you may get. There is no doubt about it. Yes or no? What you may get? You may get, it will be leading is to trailing is PL sin theta ds minus you may get sin theta ds. Yes or no? So overall the thing is you can get both axial component and normal component. Okay, now how to get the lift force from the this axial and normal component. So just like a normal component, once you got normal component, suppose, okay, so how to get Cn? Cn is the normal, it's a normal, just like this n is normal force coefficient. How to get it? Cn is equal to what? N force divided by dynamic pressure Q into S. Yes or no? Similarly, I can write Ca. What is the Ca? It is axial force coefficient. How to calculate? Ca is equal to A divided by Q infinity S. Alright. Okay. Now, so how to get the lift force from the Cn and Ca? So directly I am writing formula. No need to go for again that all these steps. So Cl lift coefficient will be Cn cos alpha minus Ca sin alpha. Okay. If alpha is less than or equal to 5 degree, it is very small actually. Then what will be the sin alpha then? For very small angle, sin alpha will be alpha. Yes or no? And what will be the cos alpha? For a small angle, it is cos 0 is 1. Alright. So that time what will be the CL? CL will be, you can say, for a small angle sin alpha becomes alpha and cos alpha, because alpha is very small, like alpha is less, it means it is approaching to 0. So what is the cos 0? It is 1. So CL will be minus CA into alpha. You can write that in this way. Yes or no? Cos alpha is 1. Sorry, just eliminate this part. Cos alpha is 1, so it becomes CL is nothing but Cn, you can say. Yes, yeah, you're correct. Okay, how it, because cos alpha is what? 1, so Cn into 1 minus Ca into sin alpha becomes alpha. Okay, all right. Generally, if you go for the value of axial force, so that magnitude is, compared to normal, axial is what? Very small. Even though vector representation I have shown here, check. That's the reason this vector representation also indicates, compared to this n, this a is very less, means axial force compared to normal force will be, comparatively it is less. Okay, so here you can neglect this axial force also, if you want, it's very small. So this part also you can neglect. Okay, so what will be the cl approximate, you can say cn. Here you had written cn, this is what cn, check, I mean n, and cn, how to calculate n upon q infinity s, yes or no, q infinity s, that will be the cn. Okay, so from here if you check, cl is nothing but we are getting cn. What is the cn? It is n divided by q infinity s, n divided by s is the area you can write chord into unit length, so you may get n upon q into c. Okay, fine. So cl, you can say 1 upon q infinity c in bracket, what is the n, check, it is 0 to c, 0 to c, p, check this part, n, pl dx, pl dx minus 0 to c pu dx. What will be the cl then? Here just for your understanding only, you can write, because if you go for the complete length 0 to c into dx, if you integrate it, then what you may get, 0 to c limit you have here. So this 1 by c I will take outside. Okay, I can write 0 to c, then pl divided by q infinity into minus, I can write pu by dx. Here I can say it is cl is nothing but approximate. Okay, 1 by c, 0 to c, I can write this pl by q infinity, you can write cpl minus cpu into dx. This formula I wanted to explain you. In middle of this derivation many things I had skipped. Okay, directly few things I have written. Just my motive was to explain one time only. One time you need to go through the steps. All steps are not required, because derivation you are not going to do in your exam, just only understanding. Okay, so what is the cl? This is the cl, I mean lift coefficient you have calculated. cpl minus cpu into dx, means if there is the wing, okay, or airfoil, because unit length you have taken, so it becomes airfoil. Okay, for this, if you have distribution of the pressure coefficient, check, this is x. Okay, I have taken one small part which is nothing but dx. This is what leading is, this is what trailing is. The chord length is nothing but, see here. Okay, and For this airfoil, okay, if distribution it is given like this, even though it is wing also no problem, the same formula you can use instead of for the, this is for airfoil, wherever, like here I have taken unit length, so here you can multiply that length. Okay, so your choice, just for understanding. So this is what, this is the pressure distribution, and this is called CPU, upper. Okay, this is very important actually. Okay, and similarly you can go bottom side also. This is the bottom side. Okay, so here bottom side, what is this? CPUL. So both pressure coefficient if you have upper and lower, and if you integrate 0 to C, then you can get CL, lift force, lift coefficient. Once you get lift coefficient, then you will get the lift. Once you get CPU and CPL, automatically you can calculate CL. So what is the conclusion? What is the integration basically? Integration is what? Integration is the area. So one very important MSQ I will tell you, they can ask to you. I'll show you here this graph. Okay, now here, okay, hmm. Here just say CP and this was X by C. Okay, so whatever the area, because this is what CPL, this is what CPU. Okay, value you can write, just say this is 1.0 plus because it is lower side, and this is the negative you can say because it is upper side. I told you upper side pressure should be less, then only you will get lift means what? Upward force. So upward force means upper side pressure will be less and lower side pressure will be more, hence you will get lift, and then your aircraft will fly. So whatever the area here it is covering, this all, this whole area will give what? It will give area. This area will give what? Area will be what? It will be lift coefficient. So MSQ will be asked you, what will be area under pressure coefficient and chord length? So area covered in the plot, pressure coefficients and chord will be the lift coefficient CL. This will be what? This, what will be the magnitude of this area will be the lift coefficient, not lift force, lift coefficient. And once you get lift coefficient, obviously lift force will be very easy to you to calculate. So here you got how to get lift coefficient from the pressure coefficient. Check, CPL is the pressure coefficient on lower side, CPU is the pressure coefficient on upper side, CL is the lift coefficient. So whatever the area here under, area under sorry, area under pressure coefficients, okay, and chord length. This is for small angle of attack, okay. So whatever the sketch of the pressure coefficients here over the upper and lower surface of an airfoil, or you can say on wing, that area between two curves in the sense what, upper and lower, two curves is the lip coefficient for a small angle of attack. The question will be asked, okay, area between two curves in a pressure coefficient and chord length, along the chord length will be lip coefficient, drag coefficient, moment coefficient. So answer will be lip coefficient. Okay, this CL is equal to 1 by C, 0 to C, CPL minus CPU dx. This is very important, very special. Many times it will be used. Okay, further. So, all right.